Briefly describe the water cycle. Briefly describe the nitrogen cycle. And briefly describe.
Oh. Briefly describe the nitrogen cycle twice. Yes, awesome. So we are going to be able to walk out of here and know the water cycle and the nitrogen cycle. First of all aboard. Make sure you have permissions. Write some things in an ecosystem that are. Here we go. There you go. Abiotic and biotic. What is it? What's abiotic? What's biotic? For all of you who came in while I was fixing the quiz today, for some reason our link was deleted, gone, not there. So I apologize. It strange to me why yesterday's was there and not today's, but so if you're watching the recording and you're like, I didn't see class, that's why. Perfect. Plants, animals, things that are living, rocks, cat souls. Good. Let's do a little bit more. Abiotic, think about the entire environment from sky to from the top of the environment to the bottom. Air, good. Oxygen, dirt. What about water? Humans are biotic, good. What else do you think? What else do you think? Thank you, Micah and Brianna, Madison, and Kaden, Brianna, for all putting things in here. Let's put water. Ooh, I like sand. Put water on abiotic. And let's put animals that live in environments near you. Okay, so I could put raccoon. Or what else? Squirrel, chipmunk. What about a rabbit? What else is abiotic? What do you think? Frogs, good. Birds. What else? Coyotes, possums. I'm trying to like look out my door. What about organisms that live in the ground? Good, worms. Kaden found the Song of Glory. What song is that? Good fish. What about those little roly-polies? Does anyone else call them roly-polies? I don't even know what the real word is. Mila thinks that's funny. They're little like beetle bugs. Pill bugs. Yeah, let's hear it, Kaden. Let's hear it. See, Riley's got me. You guys have the more official names. Oh man, that is beautiful. That's like super peaceful. I like it. Are you gonna do a dance to that song for someday for us, Kaden? How many of you were here when Kaden did his dance in his, like, was it red? Your red suit, Kaden? We've not had some talents breaking out lately. I'm slacking. Yeah. What color was your suit? Was it red? Yes. And Jaina, she was mixing us some music. We need to do that again. I feel like Mondays are a hard day for it. If you're like me on a Monday, I'm like barely making it. Wednesday? Should we go for Wednesday? Anybody else wants to? Yes, Britton, let's do it. All right. So Wednesdays. I think that's a talent. And you just knew the scientific name for a pill bug. I would love that. You guys, let's do it on Wednesdays. Okay. Oh, your wrist isn't a split. What happened to your wrist? I'm sorry, Britton. That stinks. I know, Alex. It didn't show up on mine either. I'm sorry. I was logging in. I'm like, where is our? I logged in. You want me to be completely honest with you? I logged into another meeting because I just clicked on the first link. Yeah, we're just starting actually, Emma. So I literally clicked on the first link and I went to another meeting. I was like, oh, this is not biology. So I had to jump out of that and I really quickly started another link. I'm not sure what happened. I make them like for a week at a time, so I know I had made this week. It got deleted somehow. So yes, we just started. I was getting distracted because of all of your wonderfulness. Sorry about your wrist, Britton. That stinks. So we are talking about abiotic and biotic components in ecosystems. All right. Our abiotic, remember, anytime you see that A, slice and dice those words. All right. That A means no, it's not. Biotic means living, B-I-O. That, like in bio, means living. So, not living and living components of our ecosystem. Why, might you ask? Well, we're going to talk about some things this week that are not living, but are very, very, very important, all right, to our ecosystems, which couldn't survive without these things in our ecosystems. And they're non-living. So what are those things? Well, they are nitrogen and water. You don't just make them. All right, they actually cycle and cycle and cycle and cycle. And believe it or not, do you realize that you could have, if you're drinking some water or coffee, you could possibly be drinking something that gets souls. I know, but I'll never tell. um, you could be drinking water that like dinosaurs drink. How crazy is that? How, like, seriously, if you think about your water, wouldn't it be cool if we could put like a GPS tracker on it and see where it even came from? Isn't that nuts? So I'm guessing that like the water that we drink in Ohio, if you think of our weather patterns, sometimes they come from the north, right? The northwest. Sometimes they'll creep up from like the south. So like, are we drinking water from the Gulf of Mexico? Are we drinking water from the Arctic, from Canada? Pretty crazy to think about. Yeah, I think they were, Riley. Yep. No, but I love the Animaniacs. You might have to play it for us, Xavier. Do you have it on your computer pulled up? Because I'm all about that. I know, Riley has 5 little dinos. Good. So this picture, I just want you to give, I had to say right now, we're having an in-class test on the water cycle. How would you feel? We're having an in-class test today on the water cycle. How confident would you feel in being able to say, oh, okay, no big? All right, this isn't bad. A lot of you are like, yes, or in the middle. You're meh or happy about your confidence in the water cycle. I feel like we start learning about this pretty early on in our educational journey, all right? And then we start realizing all the little crevices that water is a part of. I really am exhausted. Okay, so we not only we might think about water coming from the oceans, but do you think about water coming out of icebergs? All right, approximately 2% of all of the water is in ice. All right, we have oceans as giant water reservoirs. Right, they cycle, they go up in the air through evaporation, right? They go up to the air as evaporation, and they spread apart in the air. Right? In the air, they are the water molecules are spread very far apart until they get to a cloud where those water molecules condense and condense and condense and condense until they make a very full cloud, and then that water falls back down. All right. Water in the atmosphere mainly exists as water vapor. Some living things give off water. How might living things give off water? How might I give off water? Yeah, sweat. Absolutely. So like I feel like we learn about this really easy cycle where it's like, okay, so the water goes from the ocean to the sky, to the cloud, to the ground, like all of those things simplified as children, okay? And then we start looking at all the little places, all right? Like oh, I might give off water to the atmosphere as sweat, right? Or maybe the tree leaves absorb some water. Or maybe some water goes down deep into the ground, all right, into the aquifers underneath the ground, in the groundwater. All right, maybe they travel through rivers and streams to lakes. All right, we start thinking about the ice. So let's do this. Things that take in water and things that put out water in the water cycle. What are things that put in, put out, and take in water? I'm going to put us, humans, as sweat. You guys write some things up here too. Good. Clouds put out water. What else? Good. Plants. take in water. Animals, good. We all drink water, right? Animals take in water. Plants and animals take in water. Perfect. What else? What about in really cold environments? Good, the soil takes in water. Honestly, the clouds kind of take in water, right? And then they put it out. Good, the ice. Awesome. You guys are doing great. So what we want to put names to today is respiration and transpiration. This is when living things give off water. All right. Sweat, so to speak. All right. Respiration, like these guys right here, not just through sweat, but even through like their nostrils when they breathe, right? Isn't it gross to think that you could be drinking water that came out of one of these suckers' nose? Yeah, that's awesome. And that like these plants, eventually sometimes they get so full of water they actually have to release it. Plants almost sweat it out themselves. Isn't that cool? Did you know that? Yeah, that plants sweat too through a process of transpiration. Good. You hadn't even thought about geysers, right? Think about all the different forms of water that move around here on Earth. We've talked about water, we've talked about ice. Believe it or not, guys, I wanted to cry last night. I went out to see my nephew. It was snowing outside. I know. It was like almost 80 degrees yesterday, and now we're snowing again. Right. Clouds, right. So water comes in the form of clouds, it comes in the form of rain, sleet, snow, hail. I know, it's awful, isn't it, Diamond? Makes me cry. Okay, good. So let's do this now. I want you to explain the water cycle to me. Let's put pictures, words, and then I would love for someone to explain it. You can do it. So the water cycle, if I gave you this paper and we were sitting at desks together in a classroom and I said, draw me the water cycle.
I can try and explain it, I guess.
Yes, do it. I would love that.
I can try. I'm trying to still process everything. I've been up since like 4 a.m. So,
Oh,
it's kind of like the process of well, I guess it depends on how you look at it. I guess it's a process of animals or plants producing water that goes into the atmosphere and then goes back all the way around. They've always described it in the school like a circle. What it goes,
yeah,
and it's a cycle. That's why it's a water cycle. Uh, but at the same time, it could be the water coming from down from the earth to give us the water, and then it goes back. So it can go either left or right on the circle. Really, it's just about
yes,
how water goes from one source to the next, and then it'll so either from the atmosphere to us or us to the atmosphere.
perfect. I love that you mentioned, Kaden, that it can go both ways, right? So the water cycle doesn't have to get stuck going in one direction. It doesn't have to go from the lake to the cloud, to the sky, to the cloud, to the ground, right? That it can be us, like if there's humans or the buffalo or the bison or the plants putting off water. that is evaporated into the sky, that condensates to a cloud, that falls as precipitation, right? It's kind of like our food webs, right? Whereas there's not always one direct path all the way around, as there's multiple routes that water can actually take through an ecosystem. I also love that he mentioned that it's also kind of like a circle, right? Because you could call it the water cycle, you could actually kind of call it the water circle, right? If that helps you remember it. Not the water cycle, it's the water circle. And that can help you remember where it goes. All right. I like when I understand something well so that I can take that and understand it in other situations. Rennie, are you dancing? She's over there dancing and singing. It's precious. I wish you could see it. So we feel good about the water cycle, but we have this other element that's introduced, which is nitrogen. She is ridiculous. Oh gosh. So nitrogen. Everybody type nitrogen in chat for me. Nitrogen. What do you know about this guy? If I did ask you what you know about nitrogen, what could you tell me? A lot, a little, or nothing. I'm with you, Diamond. I don't feel like nitrogen is talked about a lot. If you could tell me one thing you could relate it to, what would that be? Good, at being in the atmosphere. Bulbs. Oh gosh. You guys crack me up. So nitrogen actually makes up 78% of our Earth's atmosphere. That's a lot, right? I mean, if you're talking about, 78%, more than half, more than 3/4 of our atmosphere is made of nitrogen. Unfortunately, our nitrogen gas in the atmosphere is not in a form that we can use it. All right. So I'm trying to think about it like kind of like an egg, right? A chicken egg. If I went and grabbed a chicken egg out of my fridge right now, could I just eat it? I could if I'm Gaston. Right. If I wanted salmonella, theoretically you could, but not really. If I didn't want to be sick or whatever. So it's a nitrogen is like an egg. It's something we have a lot of, which we typically have a lot of eggs too, but we can't use it in the original form. We have to convert it, which is why the nitrogen cycle, not just nitrogen gas in itself, is so important. So what is the fact? Nitrogen gas cannot be used by me. I need to find a way basically to cook it up, just like my egg, so that I can use it. The issue, all organisms need nitrogen to live. All right. So all of those biotic factors that we just talked about at the beginning of the lesson, all those living things, frogs, worms, people, squirrels, birds, they all need nitrogen to live. So how do we get it? How do we cook our eggs, right? How do we get nitrogen to work for us? Kind of crazy. All right, one of the very first ways we get nitrogen out of the atmosphere and into a usable form is via plants in soil. All right. So if you look over here, this plant is going to absorb nitrogen through its leaves. Does anybody remember what the doors on our leaf are called? Leaves actually have thousands of cells, and all of those cells have something that opens and closes to let water and gases out. Does anybody remember what that's called? Starts with an S. I'll put it in chat. Let's see. Let's play the game. ST. ST. Oh, almost. That's a good idea. STOM. Ooh, yes. Xavier. All right, there's stoma, or called stomata. All right, and they are like little doors on the cells of plants, and they open and they close strategically at different parts of the day. What do you think that door, when do you think that door is open? Think about if you were a plant. I know you would think it would be the day, but it's actually night. Just think about the sunshine. Think about if you go outside all day and work in the hot sun, what do you risk feeling or like if you're working out in the hot sun all day? Sunburn, good. Overheating. What about dehydration? Because you're sweating and putting off water into the atmosphere, but you're not putting it in your body. Yeah? So those stoma open during the evenings or nights. All right. And that nitrogen actually comes into the plant, and there is bacteria that lives in the roots and in the ground that actually fix this nitrogen. And what I mean by fixing is it changes the nitrogen's chemical composition to a form of nitrogen that we can use. Okay? It just cooks the egg. All right? It's called denitrification. It's the conversion of nitrate to gaseous nitrogen, which can go back into the atmosphere and be used. Okay? So over here we have our bacteria, and they make nitrogen into a usable form. Okay? So then you can see from this diagram, right? We were right here on this side, all the routes that it can take. Sometimes the nitrogen will come up and be in the plants. Some of it will go to the decomposers. Some of it the nitrogen will go from the ground to the plants to the animals through those food chains and food webs. The Gatorade, bring out the Gatorade. Does that make sense? Sometimes after the decomposers get the nitrogen, they break it apart and it goes down to the soil, comes back up through the soil to the roots of plants. So do you see how it is? It is a cycle. But again, just like the water cycle or the water circle, it doesn't always just have one direct route. So it's not always through plant roots. Sometimes it's the nitrogen, the bacteria. It doesn't always just go from the roots to plants, leaves to animals. Sometimes it'll go straight to decomposers and back to the ground. What do we need to know about this is that nitrogen by itself, we cannot use the nitrogen in its original form. You have to cook it. 1 second, baby, okay? Thank you for waiting. We can't use it. It has to be fixed by bacteria, and then it is cycled through our ecosystem through a series of things, just like our water cycle. Okay? Here you can see Some examples of that. The atmosphere has nitrogen, it going down to the plant, going to the roots. Sometimes it's in a fertilizer and runoff and it goes to the water. Sometimes there are actually marine animals that will fix that nitrogen and then legitimately like poop it back out into a usable form. That goes to the ground and becomes usable to you. I know! Isn't that messed up? All right, let's do a quick check-in call today. You guys have done a great job. All right, what is the cycle that includes respiration and transpiration to move water through the atmosphere? Draw me a line. Yes, Alex? Someone draw the line. Yes. All right, next, the process by which a plant loses water. How does a plant lose water? Almost. Yes. Cycle that includes nitrogen-fixing bacteria. Yep. Process in which an organism exchanges gases with its environment. Yes. And the conversion of nitrate gases. Good. Perfect. You guys, somehow we still got through this. All right. Whereas I know you're not leaving today, how confident, show me with your pointers, do you feel in the water cycle? Feeling good about the water cycle, yes or no? Show me your dancing pointers. Good. Now, how do we feel about the nitrogen cycle? I know it's different. It's the same but different. How do you feel about the nitrogen cycle? Good. So what I'm going to encourage you to do today is that quiz that is now unhidden. Please do that from yesterday. But I honestly, if I were you, this is a perfect lesson to get out those markers, get out some paper, and draw yourself a cycle page. Color yourself up a chart. Make yourself a flow chart. That is what I would do. Even if you think you get it, just do it to reinforce what we went through today. And I guarantee you it will help you. I know the water cycle you've all gone over, right? Yeah, so that should help you though in your understanding of the nitrogen cycle. Because much like our water goes through the ecosystem, so does nitrogen. And just like you can't like drink water from a cloud, right? Because you can't drink a gaseous form of water. It's the same thing with nitrogen. If you want an image, you're welcome to use mine too. I can go back here to the nitrogen cycle if you want to snip those. There's this one or this one. If you want to snip one of those before you leave, and then you have an example, right? Well, I won't keep you any longer. Thanks for being patient today with the link disappearing. And for those of you who popped in early when I just posted it, I enjoyed our little morning chat about cartoons. If you have any questions,